This is the story of how NASA's race to build the ultimate telescope may finally reveal secrets about life on other worlds, and why putting telescopes in space changed astronomy forever.
Five, four, three, two, one, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
We have planet Earth, which has something fundamental for us to live, which is the atmosphere. But for astronomy, it is terrible. The atmosphere causes chromatic aberrations, noise, and all that. So having a telescope on Earth is great. Of course, we have several, but you have to deal with that problem. That's why the idea of putting a telescope in space has always been around. It's a game changer. The idea is pretty basic, right? If Earth is a problem because of the atmosphere, let's put it in space. Back in the 70s, a guy named Spitzer, a top NASA researcher, said, "Let's build a telescope in space." The problem? It's super expensive. But why do it? To get better observations, study distant galaxies, planets, stars, basically the whole universe. We can study way better up there, because in space, there's no day or night. So the telescope can just keep orbiting Earth nonstop. It's constantly gathering data, so there's a lot of good stuff. The problem is, it's really expensive to run a project like this. You need to operate in the United States, right? Take NASA in the US, for example. It's a government agency, and it needs funding. The NASA budget is approved by the US Congress, which is made up of representatives from different states. So, what you have to do is convince those representatives to approve the budget for your project. But just convincing the representatives isn't enough, because a congressman answers to the people in their state who voted for them. You need to convince the population. Spitzer, he started traveling around the United States with a space telescope project in his pocket, which later became the Hubble. That's how the Hubble was born. He went around the country gaining popular support, which helped him get backing from other congressmen. With that support, he secured funding from NASA, so the Hubble telescope could be built. This all started back in 1977, but the Hubble wasn't launched until in 1990. It is a telescope that sees the universe in what we call the visible range of the spectrum. So you have the electromagnetic spectrum that goes from ultraviolet, blue, orange, red, infrared, radio waves, gamma rays. That's the spectrum. Why is this important for astronomy? Because when I observe an object at a certain wavelength, I only understand part of it. To fully understand it, I'd have to observe it across all wavelengths. For example, in certain situations like the birth of a new star, you can see stars in visible light because there is a dust cloud blocking the view. That dust cloud is opaque in visible light. First off, why is it called Hubble? It's named after Edwin Hubble, a great astronomer from the 1920s who discovered galaxies. So the main goal of the Hubble telescope was to observe as many galaxies as possible to check if what Edwin Hubble found was really right. Hubble was the first to spot and confirm a black hole, and it's made a lot of discoveries since then. Discovered storms on Saturn, storms on Uranus and Neptune. He found something really cool. It was the first time we saw galaxies colliding. He was the first to see a really important effect called gravitational lensing, a big cluster of galaxies, a huge concentration of mass, and because of that, you can actually boost the power of your telescope. You can see things that are much farther away because it works like a lens, but using gravity to bend the light. When you look at the light, you see a cluster of galaxies, and in that cluster, there are lots of little arcs like this. It is like if you grab a glass of water at home right now and hold it up to the light, That's kind of what it looks like. That's what Hubble discovered. He found out that the universe has tons and tons of galaxies. So, Hubble was super important. But soon after Hubble was launched, people started thinking about the next telescope. Because Hubble, let's be honest, it sees in ultraviolet, visible light, and a little in the infrared. So is limited to certain wavelengths. There are things it just won't detect. So they started thinking about a telescope that would complement the Hubble, mainly for infrared observations. In the infrared, you can see inside clouds of dust and gas. Like I said, dust and gas clouds block visible light, but are transparent to infrared, so you can study really well how stars are born. The universe is expanding, and the farther away I look, the more I can see things in the universe. They're moving into the red, and the farther they go into the infrared, the more distant galaxies become. So, only an infrared telescope can observe them. They thought about this and came up with a project called the Next Generation Space Telescope. That was the name back in 1996. The project went through some revisions, and around 2001, they decided that 10 meters was too big and settled on 6.5 meters. In 2002, since the name was kind of awkward, they renamed the telescope to the James Webb. So, let's talk about who this James Webb was. James Webb was a real person, a super important guy in NASA's history. He was the NASA administrator during the Apollo program, and it was under his leadership that we landed on the moon.
Okay, Neil, we can see you coming down the ladder now. I'm at the foot of the ladder. The 11 footbeds are only impressed in the surface.
In 2002, the telescope was renamed the James Webb, and that's when the whole James Webb story began. In 2003, James Webb was handed over to a company called Northrop Grumman, a major player in the U.S. military sector that also works in space. They build satellites too. So they said like this, I'm going to build the James Webb. And they start building it in 2003. The James Webb was a super complex project. Everything about it was brand new. To work in the infrared, its instruments had to be really cold, not just a little cold, but insanely cold, close to absolute zero. One of the James Webb's instruments operates at 5 degrees above absolute zero. Absolute zero is minus 4,594 graus Fahrenheit, right? Infrared is basically thermal radiation, like heat waves. If you have a device here, like a camera, the camera that's filming right now is generating heat. That heat could mess up all the data collected by the James Webb, so the equipment has to stay really cold, like cryogenic cold, as we call it. They had to develop a whole technology just to keep it that cold. They had to make a super powerful heat shield. The James Webb's heat shield is one of the hardest things they've ever worked on. It's made of really thin layers, a material that looks like aluminum foil, but isn't. It's Kapton, actually. Is a specialized company that does, and it's about the size of a tennis court. Just so you know, it's 5 leaves. These leaves were supposed to open automatically in space. Everything about the James Webb was totally new. In '96, the plan was made. By 2003, they were going to start building and assembling it. Then it went through a ton of problems. The James Webb project was super expensive and really complicated. It went through lots of revisions and was almost canceled several times. In 2011, things came to a head, and they even held a vote on whether to cancel the James Webb or not. The problem was that they had already spent a ton of money. In the end, the James Webb cost $10 billion and had some pretty interesting problems. For example, that heat shield, every time they tried to unfold it, it tore, and not just once, but multiple times. So they'd have to go back and do it all over again, causing more delays. I don't even know how long it took. Another time, when they were powering up the little motors, they had to connect them to electricity. But they plugged them into the wrong outlet and fried all the motors. Everything burned out. They even put the James Webb in a machine to shake it, simulating the launch. When they took it out, it had a bunch of loose screws. They were like, forget it. That screw isn't going to help with anything. Nothing fell off. Just leave it be. And it went through all that. Remember, guys, its story starts in '96. It was set to launch on December 25th, 2021, Christmas Day. But it wasn't that simple. It was launched from French Guiana on the edge of a European rocket called Ariane 5. It was made in California, and it traveled by boat from California to Guyana before it arrived. While it was there, a strap holding it almost came loose like. This happened just days before the James Webb was launched. It was almost destroyed because that strap came undone and the telescope could have fallen. But on December 25th, Christmas Day, over in French Guiana, the James Webb finally launched and went into space.
2, unité, top.
There goes the James Webb. The rocket takes it up to a certain orbit, but after that, the James Webb has to travel. Travel to where? The James Webb, because of the whole infrared and cryogenic thing, it couldn't stay here since it's still too hot. There are these gravitational balance spots we call Lagrange points. What that means is, if you drop something there, it won't fall toward the sun, the earth, or the moon. It kind of stays balanced right at that spot. There are 5 Lagrange points, and the James Webb was taken to one of those points called the Lagrange point L2. Is a gravitational balance spot between the Earth and the Sun. But it doesn't just stay still. It has to keep moving to orbit around that point. This spot is about 932,056 miles from Earth. The James Webb was launched on December 21st and took a month to get there. It traveled on its own, using its engine to move through space until it reached the spot. Once it got there, it entered orbit around that point. It was tense. Everyone thought something was going to go wrong. Like, now it's going to fail. Now it's screwed. To fit inside the rocket, it was all folded up. So for a whole month during this trip, we followed every step of the James Webb unfolding. It opened some panels. You know that heat shield I mentioned? Every time it opened back on Earth, it would tear. Now we opened it in space, and if it tore, that was a 10 billion down the drain. Every single little flap that opened was such a tense moment. Hubble's primary mirror is a single piece of glass about 8 feet in diameter. James Webb is not one piece. It uses 18 segments it formed a mirror about 21 feet across. People were cheering like it was the Super Bowl. Because it deployed without a hitch. That was huge. Engineers warned there were over 300 critical single points of failure on James Webb when it was launched. Nothing else important happened. Remember I said the equipment had to cool down? On this trip, it started cooling off, and we were tracking the temperature dropping too. One of its instruments, the mid-infrared one, had to get down to 5 degrees above absolute zero. And it did that just fine. So, the James Webb took about a month to get to the Lagrange point. Once it got there, it started observing not all the equipment kicks in as soon as you send it to space. It goes through a commissioning phase where they call the telescope. You turn on an instrument, take a picture, then do it another way, then do it on the other side. And the technicians here are like, oh, okay, looks good. This equipment is approved. Then they turn on the next one, doing all that until on July 12, 2022, it takes the very first image in the history of the James Webb. And from there, it started working. So, the James Webb, look at that, huh? Let's remember the story. It all really started in 1996, and by July 2022, it had just been 3 years since it began operating. And from there, he started working. Here's how James Webb works. I can observe things with the James Webb, but to do that, I have to create a project and be connected to a university or a research center. I write a project like, I want to observe Alpha Centauri, for example, because I want to study a certain type of cloud or something like that. I send all that to an institution, which receives projects from all over the world. If they approve my project, it goes into a queue. The James Webb works by project. It has not a telescope that is just scanning the sky nonstop. It only looks at objects that are included in these projects. When you write a project proposal, you have to specify which instrument you'll use, which filter, how long you'll observe the object. Everything has to be detailed in the proposal. It was launched with certain goals, like studying a period of the universe called the reionization era. The universe, as we know it, or as we think we know it, was born with the Big Bang. You start with a ton of energy. Then there's a period where it grows really fast and super energetic. Suddenly, it kind of dies down. We call that the Dark Ages. So, there was an inflation period, then the Dark Ages, and after that, the stuff from the Dark Ages starts to come back together. Stars begin to shine, and galaxies start forming. This period is called reionization. The universe is going through reionization. It's happening really close to the beginning of the universe. The challenge is that this region is extremely distant, causing its light to be significantly redshifted, shifting it well into the infrared spectrum. James Webb's main goal is to try to discover galaxies in this period. We're looking at things that happened more than 13 billion years ago, right around the beginning of the universe. The goal is to understand how the universe started and how everything formed. The first stars and galaxies in the universe, based on what we can figure out from the evidence we have. This beginning of the universe happened about 13.8 billion years ago. The farthest we can reach is where the James Webb is getting to, which is right at the start of that era. When James Webb was launched, it was really cool. Actually, when it started working in July 2022, I think within a week, 4 or 5 records for the most distant galaxies were broken. This happened because of the projects I mentioned. They had just started. The results started coming in, and people began posting about the most distant galaxy and stuff. Another really important goal of the James Webb is about star birth. That is, the little stars that form from those clouds that the Hubble can't see, but James Webb can. So, discovering or understanding how stars form is another big goal of James Webb, and he is doing it. James Webb has made tons of pictures of stars being born, observing protostars, which are like a stage before a star fully forms, and it's helping us a lot to understand the whole star formation process. Another big goal of the James Webb is to figure out how galaxies live. Astronomers divide the universe into sections based on age. The very beginning of the universe is called the cosmic dawn. Things that are a bit closer, after a few billion years, we call the cosmic noon. And the stuff closest to us here is called the nearby universe. So that's how we break it down. So the James Webb Telescope wants to observe lots of galaxies across all these time periods, because that way we can understand, basically, create a timeline of a galaxy, its life, how it is born, how it lives up until today. That's another big goal of James Webb, and it already has a lot going for it because its imaging equipment is amazing, and it captures images in infrared, which we couldn't do before. James Webb isn't a replacement for Hubble. It's a complement. Hubble sees ultraviolet, visible light, and the start of the infrared, and James Webb fills in the rest. The infrared range is divided into near, mid, and far infrared. The James Webb Telescope sees the near and mid parts, but the far infrared is still missing. We need another telescope for that. This way, we complete the spectrum and better understand everything we observe. Discovering a biosignature. What's that? Hubble discovers an exoplanet, and if that exoplanet has an atmosphere, James Webb goes in to study it. So, when a planet with an atmosphere passes in front of the star's light passes through the planet's atmosphere, and the atmosphere acts like a prism, breaking down the star's light based on the chemical elements present. If there's a chemical element produced by life in that atmosphere, it means we've found life on that exoplanet. So, one of James Webb's big goals is to find life on other planets by detecting these biosignatures. That's what it's working on right now. It hasn't discovered anything yet, but we hope it does. It's not a black hole hunter, but he has been studying black holes a lot. Because he is discovering that in these distant galaxies, there are black holes, and we still can't explain that. A really big black hole inside a galaxy would need a lot of time to be there, but he's finding black holes from way back at the beginning of the universe. So, astronomers are trying to come up with ideas about what's going on. Maybe these black holes form differently than we thought. Maybe they were already huge from the start, because the idea about black holes is that they start out really tiny, and then one black hole bumps into another, and that's how they grow, until they become these huge ones. But it is also possible that some of the big ones are born really big from the start. There, Seeds are already massive things that give rise to them. NASA has a bunch of space telescopes, and the next one they're launching is pretty cool. It's called the Nancy Grace Romang. And just a quick note about that name. Nancy Grace Romang was a woman. Remember at the beginning when I mentioned Spitzer? Spitzer was a guy who traveled to the US, but inside NASA, there had to be someone who believed in his idea, and there was this woman, Nancy Grace Romang. She is known worldwide as the mother of the Hubble because she was the one at NASA who supported the idea of the Hubble. Now, she's going to be honored with a new space telescope, possibly launching in 2027, called the Grace Romang in her honor. The goal of this telescope is kind of to complement the others. It'll observe in ultraviolet and see things more clearly. It has a wider field of view, which is great for observing certain objects, so it's going to do a lot of studies. Also, to add to those other two, both the Hubble and James Webb, but this one is more connected to Hubble, because Hubble is nearing the end of its life, so it might not work for much longer. So you need something to replace it, and maybe this is it. There's another really cool telescope that NASA is going to launch called the Habitable Worlds Observatory. This telescope will basically release as flower in space. It looks really cool. It will send out a probe that opens up like a flower. The purpose of this is to block the star's light, and this telescope will try to see planets really close to those stars' planets that are in the habitable zone, just like Earth is in the habitable zone of the Sun. And there's this big dream astronomers have called LAVOIR, which stands for Large Ultraviolet Optical and Infrared Telescope. So it would be a telescope covering all wavelengths, ultraviolet and infrared, with a huge mirror. Like the James Webb, it would fold up and then unfold in space. That's why when James Webb unfolded, everyone were really happy, because this LAVOIR idea finally makes total sense now. That's today's story. If you enjoyed the video, please like, share, and subscribe. It really helps us keep bringing science to everyone in a fun way. See you, Space Cowboy.